Exercise 836 is trying to get you to use your knowledge of E1 and E2 reactions to think creatively about how you can make this molecule here. Imagine that that molecule is a medication that would save somebody's life, or a very valuable molecule that would be very expensive for someone to buy, but that you can make from a less expensive starting material. So the question is, what's the best way to make that? Is it better to use this recipe on top, or better to use this recipe on the bottom? And why? Well, the difference between these is the top reaction is an E2 reaction and the bottom is an E1. And you can recognize that in a couple ways. The first, you'll notice that you have this strong base in this top reaction, sodium ethoxide. The metal loses its electrons to the oxygen that it's bonded to, which then becomes fully negative, and then the ET is the ethyl group, so sodium ethoxide, strong base. On the bottom, you have an acid, and not only that, it's a strong acid and a concentrated acid. That takes this terrible leaving group, this OH, and it protonates it. It puts an H on there. It turns it into an H+. That can then pop off of the molecule as a leaving group, and you would get this carbocation here. Now, this is where you can see the difference in the two reactions. If you're trying to think about where this base is going to steal a beta hydrogen, remember the carbon that has the leaving group on is the alpha carbon. Any carbon bonded to it is a beta carbon. Notice that this carbon up here does not have any hydrogens on it. 4 bonds are already drawn and they are all to carbon. There are no hydrogens there, so the base can't steal a hydrogen from there, and you can't form a pi bond in that direction. But there are pi bonds in this other beta, on this other beta carbon, and the base could steal those. The electrons can go toward the leaving group and kick the leaving group off. And that would form this product that we want. Compare that, though, with what happens in the E1 reaction. In that case, we have a carbocation, and anytime you have a carbocation, you have to worry about carbocation rearrangements. This carbocation is bonded to 2 carbons, so it's secondary. Going to the bottom, also bonded to 2 carbons, secondary, but the carbon to the left is bonded to 1, 2, 3, 4 carbons. It's quaternary. That's a much more stable position, and so this methyl group, the smallest thing there, takes its electrons and moves over. You get the carbocation rearrangement. And the new molecule you have looks like this, with the carbocation on top. Well, that's very different. We can see already that's not going to give us our product. The carbocation is now the alpha carbon, so that alpha carbon is changed. And then next to it we have 3 beta carbons. They each have beta hydrogens that the base could take. So you could imagine forming 3 different products here. You could imagine forming a pi bond to the beta carbon to the left. You could imagine forming a pi bond to the beta carbon going up. Or you could imagine forming a pi bond to the beta carbon to the right. Now you'll notice the most substituted one, and therefore the Zaitsev, and the major product for any E1 reaction is this one on the right. The other 2 are less substituted to different degrees. But you'll notice that none of these give you your product here. So if you had an incomplete understanding of how these mechanisms work, and you're like, well, it's an elimination reaction, I just want to take this one thing off, who cares about the mechanism? In one case, if you were lucky, you would get the product you wanted. But if you chose the E1 reaction, none of your products would be what you wanted. You would have a bunch of junk, and then whoever paid for all the time and all the materials, all that would be lost that you used. So considerations about the mechanism of an E2 or an E1 reaction are important because, as illustrated in this exercise, they allow you to produce different products. And in this particular one, you would want to use the reagents for an E2 process because that avoids a carbocation rearrangement. The concentrated acid with the poor leaving group that involves an E1 process, which involves a carbocation rearrangement, which leads to products that we don't want. So you could see how you could apply your understanding of different aspects of elimination reactions in an exercise like this.